Hello students, welcome back. Let's go to problem number 2. This time let us study inferential statistics of proportion. A bank randomly selected 253 checking account customers and found that 184 of them also had savings account at the same bank. Okay, here's a question associated to this setting. Which approximation is more appropriate, Z or T? So do we take Z, the normal approximation, or T approximation? Clearly, 253 is bigger than 100. So this is going to be Z approximation problem, or the normal approximation problem. Okay, that was easy. Now let's go to confidence interval problem. We want 98% confidence interval. So here's the initial picture. Outline, center, end, and shade. So here's a picture. Oh, by the way, I should have asked you the center. What is the observed proportion? 184 out of 253. So 184 out of 253, 184 out of 253, and 0.7273 like this, so 72.73% or approximately 73%. That's the observed proportion. That's the proportion the sample study gave us, so that goes to the center. Okay, and then 90%, 98% in the middle, 1% here, 1% there, total adding up to 100%. All good. Now let's go to the solution. So how do you use this Z-score formula? Z is end minus center over SE, and we want to find out minus center, so far so good, over SE. Where is SE? If you had standard deviation as before in this kind of problem, and you had the standard deviation over square root of n, but in this case, what is the SE? That's where we begin. It's a proportion problem, so we need these kind of adjustment. Center is the proportion given, so 184 out of 253. And then SE computation is, remember this formula, square root of P1 minus P over N. So 0.7273, this one minus of that over 253, and then take the square root. Run your calculation, and this is your standard error. Okay? Alright, we got the standard error, so we can set up the Z-score computation. End minus center over SC is the Z statistics, and that's supposed to be negative 2.33. Well, we have 1% here. So in the Z table, let's see, here's the Z table. Yeah, this is Z table. 1%, look for 1%. Where is it? This is the closest, 0.0099. So that's negative 2.33. Indeed, negative 2.33. So solving this equation, flip this denominator to the other side, and then flip the center to the other side, and we have this computation. Run your calculator, and here we go. The detailed computation is left to the student. Stop the playback and do it carefully. Now, from the center, we subtracted to get this. So all you have to do is to add, go plus, and you're going to get to the other endpoint. So change this minus to this plus, and that's how you get the other endpoint of the interval. Here's a conclusion, the confidence interval. 666.2% to 79.3%, basically. Okay, all right. The confidence problem the confidence interval problem is done. And now let's do hypothesis testing. The bank targeted 80% of their checking account customers to open savings account as well. Does this study suggest the bank met the target? Set up the hypothesis. Okay. The null hypothesis is mu is approximately equal to something. In this case, instead of mu, I may have to use proportion pi. In any case, equal to some proportion. And 184 out of 253, that proportion came from sample, so that's not it. What's the other proportion? Of course, it's 80%. And there goes my null hypothesis, about 80%. And the other true proportion is actually less than 80%, thus did not meet the target. That's the alternative hypothesis. Another way to see it, 184 out of 253, we got something like 73%, so that's less than 80%. So yeah, that's another indication. So less than 180. By the way, if you're not comfortable with pi as the Greek letter associated to p, it's okay to use mu. As far as I'm concerned, whatever character we use here, I'll accept it. Don't use bar. It has to be a parameter, so it has to be some Greek letter. Mu is usually the best deal. Now this is proportion, so to be really precise, you'll have to use Greek letter associated to proportion. So pi is a little bit more appropriate, but it can be a little bit confusing, you know. Other than this course, in a math course, if you say pi, it means something else. It's 3.14. It's a little bit different here. You can use mu if you want to. Okay, all right. Let's test these hypotheses. Here's the initial picture. %, did not meet the target, so go down. And where is the critical value? Get this critical value and then compare this with observed proportion of 73%. If 72.7% falls here, blue region, close enough to null, so null wins. We accept null. If you fall here, then too far away from null, so null loses, so we accept alternative. Remember, the center is null. Okay, alright, let's find out the critical value. The typical deal, we have to use the z-score formula, n minus center over SE. N minus center over SE. What's SE? Standard error, do you guys remember the formula? Square root of p1 minus p over n. There goes the computation. The same formula, but it's not the same value as the one you saw here. You see, not the same value. Same formula, but not the same value. Why? Because here we use observed proportion from the sample study, because this is confidence interval problem. Now this is a hypothesis testing problem, so we use null proportion. So same formula, yes, same SE formula, but different number. Different center, so different number, of course. So we get a little bit different SE as before. So if you use previous SE, you'll lose some credit. Now we have center and SE, so you can find out the critical value using the z-score formula and minus center over SE. Critical value minus center over SE is, well, z-score associated is to 1%. We already checked before, it's -2.33. So Flip this denominator to the other side and then flip also this null. You get this computation. We get 0.74 something, 74% at the very least, and previous value, the sample study gave us 73%. You see, less than 73%. This one is greater than 74%. So the observed proportion p bar fell into alternative region, too far away from null, so we reject null. So, see the idea? You can clearly see how far this p bar is from the null, and then how far is too far and how close is close enough will be given by the critical value. So once you do your computation and then compare it with the picture, the conclusion is easy. Okay, we have enough time left, so let's talk a little bit about probability value approach. Similar idea, but initial picture goes like this. We are not looking for the critical value or anything like that. Null is here and observed proportion just goes there, and then find out the probability p-value all the way outside. It's so far away. This shaded region is really small, so it's really hard to see, but there should be some purple shading there. And the idea is whether the probability for type 1 error is greater than alpha or less than alpha. Oh my, this is conceptually really hard to understand because they are both conditional probabilities. Let's not go too deeply into that. And then let's follow the probability value method. So center and SC, the same computation as before. And then find the probability using z-score and minus center over SC. Calculate, you're going to get negative 2.892. So negative 2.89, and look up the z-table, negative 2.89. Wait, it is negative 2.89, 0.0019. It's very small, smaller than 1%, certainly. So what does that mean? Smaller than alpha, so accept alternative. Bigger than alpha, then accept null. But then again, that conclusion is really hard to understand, so I do not recommend this method. So don't use it unless you know what you're doing. But if you want to use it, here we go. It's not accurate, but it works most of the time. The p-value here, the probability value, is roughly speaking, roughly corresponds to the probability that null is right. So if p is big, then big probability that null is right, so we accept null. But less than alpha, so no, null is not going to be right. That probability is not high enough, so we are rejecting it. Let's go to hybrid method. Initial picture is almost the same as critical value approach, except that we do not expand it with respect to null, but this is standard normal, so go from 0, and here goes a z-statistic. And then the critical z-value for 1% was 2.33. Negative 2.33, excuse me. Yeah, this is the same computation as before. Negative 2.33. And then compare that with observed z-statistics given by that 184 out of 253. Calculate it and compare. Now here's the hard part. One is greater than the other, but what does that mean? If you understand that, that's great, but it's really hard to understand. So again, don't use this unless you know what you're doing. If you use critical value approach, then the final decision part is easy.